नाउ सीरीज रेजोनेंस। अब सीरीज रेजोनेंस को हम लोग पूरा डिटेल में समझ लेते हैं। सीरीज रेजोनेंस, व्हाट इज मीनिंग ऑफ सीरीज रेजोनेंस एंड कितना करंट होगा, कितना इंपेडेंस होगा, कितना एडमिटेंस होगा और कितना इलेक्ट्रिक रेजोनेंस के लिए हमारी हमारी कंडीशंस क्या क्या बनेगी। ओके, सो नाउ फॉर सीरीज रेजोनेंस कंसीडर a pure inductor of inductance L, ideal capacitor, we consider that is ideal capacitor, that is C, and resistance, pure resistance of resistance R are connected across the alternating source of EMF, that is E is equals to E naught sine omega t, this is plus minus. Now this is a series combination, and in series combination the current should be same, so I should be equals to IL is equals to IC is equals to IR. So in series combination current should be same, so this is IL, so this is, इसके अक्रॉस में EMF EL रहेगा, इसके अक्रॉस में EMF EC रहेगा, इसके अक्रॉस में EMF ER रहेगा. So these are EMF which is divided into three parts, that is for inductance, for capacitance, for resistance. So EL is plus EC plus ER should be your total EMF. So that is E is equals to, what is our equation, from EL plus EC plus ER. So the addition of EMF across inductor, EMF across capacitor, EMF across resistance should be the total EMF which is applied to the series combination of LCR circuit. Now, so for this series combination, current should be same, and there is division of voltage, yeah, division of EMF. So E is equals to EL plus EC plus ER. So this is for the series combination. We calculate the equation for impedance. So impedance is denoted by Z, and the equation for the impedance is under root of R square plus XL minus XC का whole square. So where impedance is total resistance या total opposition offered by the series combination, by the series circuit to the current flowing to the circuit, yeah, for flowing total current flowing through the circuit. So that is called as impedance. So what is our impedance? The impedance become the resistance offered, yeah, the total opposition offered by the series combination to flowing the current through the circuit. So that is called as impedance. And the impedance, SI unit of impedance is ohm, and it's again volt per meter, volt per ampere. Okay? And the dimension of this one is again L2 M1 T minus 2 I minus 2. So this is the dimension for impedance. So Z is equals to under root of R square plus XL minus XC का whole square. So where XL and XC is a impedance, sorry, this XL is the inductive reactance, where XC is your capacitive reactance. XL is your inductive reactance and XC is your capacitive reactance. So what is XL? Again, XL is a resistance offered by the inductive coil to flowing the current through the circuit. सर्किट में करंट फ्लो कराने के लिए जो रेजिस्टेंस ऑफर्ड करने का काम करता है, सो वो काम करता है XL. और सिमिलर पोजीशन फॉर XC, अगेन XC is a resistance offered by the capacitor to flowing the current through the circuit. फिर से करंट, सर्किट में से करंट फ्लो कराने के लिए जो रेजिस्टेंस को ऑफर्ड करता है कौन, कैपेसिटर, उसको कहा जाता है XC. So that is called as capacitive reactance. So XL and this is XC. For this electric resonance, your XL should be equals to XC. This is the condition for electric resonance. Yeah, we can say that electric resonance occurred only when inductive reactance is equals to capacitive reactance. Your XL should be equals to greater than XC. So when your XL should be when XL is equals to XC, so this occurs the electric resonance. Clear? So when there is XL is equals to XC, if I am putting here, so we get this is the term is 0. So Z is equals to, this is under root of R square plus 0. Clear? Because this is XL is equals to XC. So Z is equals to, this is under root of R square, and we can say that Z is equals to R. So R is a pure resistor of resistance. So Z is equals to R. The meaning of Z is equals to R. So this circuit is act as a purely resistive circuit. And when this circuit is act as a purely resistive circuit, so the phase difference between EMF and current are zero. So that means EMF and current are in a same phase, because the value of impedance is equals to your resistance, and value of impedance is equals to your resistance, then this circuit is act as a purely resistive circuit. And when it is act as a purely resistive circuit, so the phase difference for the resistance is EMF and current are in a same phase. EMF और current आपका same phase में रहेगा. That means the phase difference between EMF and current is zero. Clear? So then Z is equals to R. So we minimizing this value. So that's why the current is minimum here. So when your impedance is equals to your resistance, so this circuit is act as a purely resistive circuit. So due to minimizing this value, the impedance is minimum. So यहाँ पे Z कितना हो जाएगा? Minimum. So your Z is minimum, and according to the relation of Ohm's law, so we know that E is equals to I into R, and here Z is replaced by R. So this is replaced by Z, and Z is I मैं यहाँ से बना लूँ I is equals to E divided by Z. If this is Z is minimum, but obvious this is due to relation of inversely proportional, current is maximum. So यहाँ I का value आपका maximum हो जाएगा. So the current is maximum, and when the current is maximum, so Z is minimum, current is maximum, and 1 upon Z, मतलब 1 upon impedance is nothing but your admittance. So 1 upon impedance is equals to admittance. Again it means that, so this is considered as a first point. We अगर मैं यहाँ से इसका characteristic बना लूँ, so this is first characteristic. Now this second characteristic, and what is third characteristic is the admittance should be maximum. Admittance कितना हो जाएगा ये? Admittance is maximum. So your admittance is maximum. So why admittance is maximum? Because there is a reciprocal. This is a reciprocal impedance is nothing but your admittance. So Z is minimum. Why Z is minimum? Because we are minimizing this value. So this Z is equals to R, and when Z is equals to R, so this circuit is act as a purely resistive circuit. So the impedance is minimum, and according to the Ohm's law, E is equals to IR. So R is replaced by Z. So E is equals to I into Z. So I is equals to E upon Z. So due to relation of inversely proportional, current maximum and 1 upon Z is admittance. So that's why this is minimum. So admittance is maximum. So admittance is maximum. And the next characteristic of this one, admittance, यहाँ पे हमारा इलेक्ट्रिक रेजोनेंस तभी बनता है जब आपका वैल्यू XL should be is equals to XC. So we are putting here XL is equals to XC. Inductive reactance should be equals to a capacitive reactance. Then and then this electric resonance is occurred. And when this electric resonance is occurred, XL is equals to XC. अब यही इक्वेशन को लेकर के मैं सामने का इक्वेशन हम लोग अगर सॉल्व करेंगे, so what do we get the from further equation? So what is our further equation? XL is equals to XC. So XL is equals to omega L, and XC is equals to 1 upon omega C. So XL is your inductive reactance, where XC is your capacitive reactance. The value of XL is your omega into L, where omega is your angular frequency, L is your inductance, and 1 upon omega C. Again, omega is your angular frequency, and C is your ideal capacitor here. So again, this is omega square is equals to 1 upon LC. Omega is equals to 1 upon under root of LC. Then again we know that omega is equals to 2 pi f. So that is 2 pi into frequency. So this is 2 pi f is equals to 1 upon under root of LC. So again f is equals to 1 upon, this is 2 pi under root of LC. So this is a series resonance. For series resonance, so this is replaced by S. So this is a frequency in series combination, yeah, series resonance. So Fs is equals to 1 upon 2 pi under root of LC. So Fs is equals to 1 upon 2 pi under root of LC. So this is the equation for a frequency in series resonance. ये इक्वेशन होगी आपका फ्रीक्वेंसी के लिए, किसके लिए? सीरीज रेजोनेंस के लिए. अब सीरीज रेजोनेंस का हम लोग ग्राफिकल रिप्रेजेंटेशन देखेंगे. अगेन वी सी द ग्राफिकल रिप्रेजेंटेशन ऑफ सीरीज रेजोनेंस. चलिए, तो यहाँ हम लोग अगर इसके मैं कैरेक्टरिस्टिक की बात करूँ, सो the characteristic of this one, characteristic. So what is characteristic of a series resonance? So series resonance occur only when XL is equal to XC. Inductive reactance should be equal to a capacitive reactance. Impedance आपका minimum. So when the impedance is minimum, current आपका हो जाएगा maximum. And when there is a maximum current, so impedance admittance is also maximum. Clear? So XL is equal to XC. So we get the equation for frequency in series resonance. So here the current is maximum. आपका current यहाँ maximum आ गया. So when the current is maximum, so it means that current आपका maximum है. If I am taking the graphical representation, so graphical representation of series resonance. So अगर मैं graphical representation ले लूँ तो graphical representation कुछ ऐसे लिया जाएगा. So we are taking current on the y-axis. So we are taking there is I naught, and here there is a frequency. So this is a frequency, that is Fs. Because we are taking for series resonance, so current is maximum. Current कितना है हमारा maximum, and when there is a current of maximum, so it starts from initial value, so going into a maximum stage, again it comes to a minimum stage. So for this particular point, so we are getting this is F max. तो ये आपका F max हो जाएगा, और यहाँ से आपका current जो है, so this is I guess. So this is a graphical representation for the series resonance. These are the equation for the series resonance, and this is the first electric resonance, that is called as series resonance. ये आपका पहला series resonance complete हो गया. So in series resonance, so again see that in series resonance, again देखिए यहाँ पे हाँ एक चीज यहाँ हम लोग बोलना भूल गए कि जैसे अगर मैं यहाँ पे कुछ important note की बात करेंगे तो important note यहाँ से हम लोग क्या कहेंगे? So what is the important note from this one? Now see, this is all about the graphical representation. This is about the equation of frequency in series resonance. This is the equation for Z is equals to R, impedance is equals to resistance. जिस समय XL is equals to XC है आपका. Now see, when you are applying, this is very important. Now listen carefully. So when you are applying AC source to the electrical appliances, जिस समय AC source हम लोग electrical appliances को connect करते हैं, so what happens? So electrical appliances को यहाँ से we are receiving the frequency, ये यहाँ से frequency emit होगी, and that is emitted frequency is received by this series combination. Due to receiving this series combination, so all types of frequency are present. That means it has a minimum current, the frequency which has a minimum current, or the frequency which has a maximum current, and the frequency which has a minimum current and frequency which has a maximum current. So this AC circuit only receive those frequency which has a maximum current. So it means that this circuit, this is all together circuit, is receiving the frequency which have a maximum current. It is also called as it accept the frequency which have a maximum current, and that's how it receive the frequency, it accept the frequency of maximum current. That's why this circuit is called as acceptor circuit. इसको कहते हैं हम लोग, this is called as acceptor circuit. So this is called as acceptor circuit. Why it is called as acceptor circuit? Because it accept the frequency which is have a higher current या maximum current, and reject those frequency which has a minimum current. और वो frequency उस चीज को reject करेगा जिसमें current minimum रहेगा. So that's why it is called as acceptor circuit. So that is called as acceptor circuit, and this is altogether the concept of electric resonance, and this is the first is series resonance. Is it clear?